Hello everyone. This week I'm making some changes, and one of them is to add reviews because and these are like quick reviews that we did in the class in the beginning of the class. I think we're missing that, and hopefully this is going to sum up the concept a bit better. So I'm gonna add videos for each class, probably on that class. At the end there's going to be a review, and you can also check that review video before the next class as kind of to remind ourselves what we went through. And so since we didn't do that on the previous class for last week, I'm kind of summarizing classes, so some of the concepts. First thing, I'm also going to have some hopefully encouraging quotes that I used to have in class. So today I picked a quote from Stephen Hawking. He actually died on the Pi Day, March 14th, 2018. And Einstein, that was also Einstein's birthday. So one genius dies and one genius kind of is born. And so he said, however difficult life may seem, there is always something you can do and succeed at. It matters that you don't just give up. So it's very important. I know this is tough situation we're going through, and physics is like long classes and it's hard. Although you have a background, we are doing things differently. So if you don't follow the notes, follow the videos, you're still going to miss those things. So I really ask you just not to give up. Let us know how can we improve things for you, and we will do our best. So the first concept that I want to quickly review is friction. And so for the friction force, again, it starts from the assumptions, right? We think about the homework layout before we solve problems. So just see if you have a frictional surface. Is it rough surface, or is it lubricated, or is it smooth? Then we don't have friction, right? So just kind of check if you are dealing with friction. Next thing you need to think about is, if we know that there's a frictional surface, is there friction? Okay, just because it's frictional surface, it doesn't mean that we will have friction. So you need to think about the acceleration and see which way the object is moving, if it is moving at all, and if there's an acceleration that way, and do we really need friction to create that acceleration? Okay, so again, the clicker questions hopefully is really helpful, because we did go through some of those things. If it is not clear, please go back and study before the next exam coming up, which is on April 1st, as I've been emailing you guys. So find out if there's friction, okay? And if there is, then think about what type of friction you're dealing with. Are you dealing with a static friction or kinetic friction? Static friction is the case for, let me just write that first. This is the case when so the friction happens between two meeting surfaces, right? If those two surfaces are not moving relative to each other, then you have static friction. So in the case of, for example, that this was a kind of a little bit tricky case, but you have it in the project assignment. The tire rolling but not skidding, and we also ignore ABS braking in the homework problems because of this. If it is not skidding, then you have a static friction, because the point on the tire touches the ground at one point, and that point is not moving relative to ground. Okay, so it kind of kisses it once and then moves on, right? Another point and another point. It just like happens once. So that is also static friction. Although the car is moving, the point on the tire relative to the ground is not moving. That's why we say this is static friction. So this is really important. And for static friction, it is something that builds up. So what we need to think about is there is an equation given, but this equation has a condition. So it's only for the maximum, and this is mu s n. So the condition for this is if the object is on the verge of moving. In any other case, you cannot use this equation. Okay, so just because you know that, yes, there is static friction, but I'm not sure, it's not given it's on the verge of moving, but I know that I need static friction because it's like maybe there's an applied force and maybe there's the acceleration is 0, but I need an opposing force to that to keep the object stationary or something. So I do have a static force, but I don't know if it is this. Then do not assume that you can use this equation. If it has to be clearly given to you that it is on the verge of moving. Okay, but we also use this equation to figure things out. So maybe you're not sure. They don't even say, okay, so they say find the acceleration, but they don't even say if there's an acceleration. Maybe that acceleration is 0, or maybe not, but or maybe like if you remember the example problem we did, we don't know which way it is moving. Okay, so because when the motion direction changes, friction will change. It's going to change your free body diagram, and it is going to change your values in algebra as well. Okay, so you got to be careful. And some on those cases, as I done an example earlier, we use this to figure things out. Okay, I check like connected objects, for example. I check the rope line forces, ignore the internal forces. So I'm looking at this system and looking at, okay, these are the forces. Maybe there's some weight force, there's some other applied force or something. I look at those and then see which one has more and take the difference and look into how it is comparable with the static maximum friction. Okay, and then we will be able to figure out, okay, maybe I don't have enough force. It is the net force I'm getting from the system is less than the maximum static friction. That would mean the system is not moving yet because we don't have enough force to overcome the static friction. Okay, but if we have more, then okay, I don't have a static case, I have a kinetic friction because the system is in motion. So please check those, check that example problem that I've shown earlier, because it really, we did investigate that hopefully nicely. So the kinetic friction, if we already figured out that it is moving and it is accelerating. It doesn't have to accelerate to have kinetic friction. You just need to make sure that it is moving. So it could be a constant velocity, 0 acceleration. But the good news with this is, as long as you figured out that it is moving, then you can use this equation anytime. There's no conditions except that object, the surfaces that where you have the friction should be moving relative to each other. Okay, and there is only one value for kinetic friction, but static friction is something that builds up, starts from 0. And again, it just because the surface is frictional doesn't mean that you will have static friction. Maybe it is 0. Like think about two boxes stack on top of each other, but they're not moving at all. Then there is no friction between the boxes or between the bottom box and the surface either, because if there was a friction, the boxes would accelerate that way because there's no other forces to overcome, right? So think about those as well. But static friction is something that builds up starting from 0, goes to maximum value at mu s times n, and then maybe you keep like pushing an object and you're kind of reaching this on the verge of moving case and you're getting the maximum static friction, and then you're applying a little bit more force that is going to result in the motion of the object. So then you're gonna look into the kinetic friction. Now I no longer have maximum static because my object is moving. Now I'm gonna revise my equations, and usually this kinetic friction is much less than static maximum. Sometimes it is equal, most of the time it is not, it's much less. And the reason for this is usually mu k is much less than mu s. Okay, they have the same normal force, as you can see. So this is kind of how we deal with friction. And the homework solutions will be also posted tomorrow. So again, this concept is so important for the coming exam, which is on April 1st. So please revise those. And if you have any questions, let me know.